Hello and welcome to this section. In this class, we will learn the homework assigned in the last class, baseball that can dance. For your quick mastery, please be sure to watch the content of this section after completing it yourself. So let's open the editor directly, and we can directly establish an absolute positioning environment application called Dancing Baseball. Click the Create button. First, we will add a page under the front end, and then we will select the page. First, we will add the material of our 3 baseball clubs, and we will select the image widget on the left to randomly on our stage draw a picture. Okay, let's adjust the width and height of the fat ball to the same. Here we set it to 50-50. Then, please note that our baseball can rotate in the middle. We can see the effect. It can rotate in the middle. What should be set because we use rotation? It is its central origin, so we must form such a habit. Whenever we are involved in rotation education, set its central dot to 50 and keep it in the center. Then we can take a look at its effect. It has a background color, so we can also set the background color of the page. Then there is a material of 3 baseball bats. In fact, the order of the material doesn't matter. Here we'd better upload it according to its approximate order. Since we have set the width, height and origin of a baseball here, we can directly copy and paste 3 copies of the remaining baseball and then replace its material. For example, the material of the second baseball is called such a material, and then the material of the third baseball is called for such a white baseball material. Let's set its position slightly. We keep the distance between the 2 small balls at 100 pixels, and the distance between the 2 small balls is 200 pixels. If we make it equally spaced on the left and right, we can subtract a 200 from 375 and divide it by 2, that is, 175 divided by a 2, and there is roughly more than 80 left 1 pixel, so we set the x of the first ball to an 87, and then the second ball increases by 100 to an 187. The third ball is added by 100 on the basis of this ball to become a 287. In this way, we basically do a good job in the equal spacing of the 3 balls, and then unify its y-axis to a 300. Well, we have finished making a basic material of 3 baseball bats. Next, we will add a track effect for it. We can add a track effect for the first baseball. Let's first look for such a baseball. How many pause positions does it have? First, it jumps from here to the top, then falls from the top to the bottom, and then falls to the bottom end. Why can we see him jump in place, then return to his original position, and then go to such a position in the upper right corner, then he came down, jumped in place and came back. Then we pause here and return to such a position. So we don't have to remember so much. We can give it such a key needle for each needle. So we select such a baseball. We first add a track for it, and then we hit the first keyframe at its initial position. Generally speaking, for such equally spaced keyframes, we can directly maintain a relative time interval, keyframe, so in the second time interval, we can mark a key pin every 0.5 seconds. We can mark it with the second key pin in 0.5 seconds, and then we can see what its next position is. It's a pixel shifted to the upper right corner, right? What does it translate to the upper right corner? X increases and Y decreases, so first subtract 50 from its y-axis to become a 250. Similarly, if it wants to translate to the right, then add a 50 to 87 to become a 137, so does it come to such a point, and then does it come to a position of such a ball? When we move one of his cursors to 1, we put a plus sign. Where is he going next? He's going to the position of the ball, isn't he? What's the position of the ball? It is 300 of 187, so we directly write in property of such a key needle, which is a 300 of 187. In fact, we can already notice here. You see, now if we roll, how does such a ball roll? It's a curve rolling, isn't it? Why is the curve rolling? That's because our trajectory type is curve, so here, according to your own preferences, you can change it into a curve or a straight line. I think the straight line is better, so it's changed into a straight line. So after we hit the key in 1 second, let's go back to 1.5 seconds, and hit the next key pin in the same way. Let's select such a key pin, subtract a 50 from its y-axis to become a 250, and add an x plus a 50 to become a 237. Then he comes to such a position, and then hit a key pin in 2 seconds a key battle. 2 seconds later, we click a plus sign. Where is the 2-second position? Is it the same as such a coordinate, that is, a 300 of 287? So we go back to this track and select the 2-second position, which is a 300 pixel of 287. You can see that such a baseball already has such an effect of a track, but we seem to have missed it. One thing is this baseball. He can take off in place, right? When he came to such a point, he jumped in place and then went down. Oh, so let's change this place. What's he jumping in place? Based on its original position, its x does not change, but the y-axis changes, so you change its x back, and x is still 187. So we can see that he completed a process of taking off in situ, and then we hit such a key player again in 2.5 seconds. In fact, we all know the key of just 2.5 seconds, that is, move 50 to the right, and then move 50 up, so the y-axis is 250, and then 237 here. Similarly, we hit the next keyframe in 3 seconds. What is the keyframe in 3 seconds? Is it such a position? In fact, we now know that 300-20087 is okay. We can come to the same position here, and then in such a position, but I will jump in place, so we will hit the next key needle in 3.5 seconds. What is the in-place pump? The x-axis does not change and the y-axis changes, so if we change the y-axis into a 200, it will jump in place, and then it will return to the original position. Therefore, we copy the keyframe of 3 seconds, and then paste it in such a position of 4 seconds, so he will come back. Then where will he come next? He will come to the following position, right? When we return to the following position, we also give him a time. Here, we come to a position of 4.5 seconds, and then put a plus sign. What is the position of 4 seconds? Is it that one of its y-axis becomes larger, and then x is actually consistent with that here? How much is x here? It's 187, so we can still write him here that his xx is 187, and then the y-axis should be larger. Let's try 400 first. 400 seems to be more appropriate. Let's come here, just a 400 of 187, and then what will happen to him in 5 seconds? Is it back to a default position? So we can copy a keyframe at 0 seconds. Let's go to a position of 5 seconds and paste it. We can take a look at such a keyframe. You see, at least in one direction of movement, we have done a good job in the movement of such a ball. But we found that there are still some shortcomings. What is it? What should this ball do besides or sports? You should also rotate, right? So we have to add a rotation angle to it. So how many degrees do we let the first key person rotate before? Rotate a 180 degree. Here we write 180, and we can see its rotation effect. Here is 180. Turn it here, and then in the same second, we add 180 degrees to make it a 360, add 180 degrees to make it a 540, add 180 degrees to make it a 720, add 180 degrees to make it a 900, and add 180 degrees to make it a 1080. The same, add another 180 degrees to make it become a 1260, add another 180 degrees to make it become a 1440. Is it going to start to rotate here? Because finally, make an angle of it become 0 degrees, so it must be set to 720 for a rotation angle here. First, let it decay by half, and then when it reaches 0, it will completely decay to 0. This is the end, it's a whole cycle. Let's see the effect again. Have we already done a good job in the jumping effect of this ball? Okay, then we can go to the next track. If we add the trajectory of the next ball, we should ensure that this trajectory is completely consistent with the time point of this trajectory. Is that particularly troublesome? So what will happen to us? Yes, we will think of using the timeline, because what is the greatest function of the timeline? There are 2 tracks in Tongling, so we add another timeline under the page. We drag all such materials into our timeline. Let go. Okay, you can see that it has an effect of such a timeline now. Then change the duration of such a timeline to a 5-second one. There are 11 in total. The key is after that, if you type 1 every 0.5 seconds, 5 seconds is actually enough. Let's take a look here. When the ball moves up for the first time, should the ball also move down? So when he is at 0 seconds, we will give him the first key needle, and then we let him go to our 0.5 seconds. We will give him the second keyword at 0.5 seconds. What is the second keyword? Is he going to move down and come to such a position? So we first subtract a 50 from its x-coordinate to become a 137, and then we have to move it down a little, so it becomes a 350, but we jump to such a position. Then, similarly, we let him go to a position for 1 second. What will it do in 1 second? It will go to our initial position. What is the initial position? It's our 87. Here, we subtract a 50 from it to become a 300. You can see what such a track is like at present? It's a curve, so we change such a track into a straight line, and then we get used to it directly this time. We do it together with its rotation angle, which is 180 degrees here, and then it's 360 degrees at the next position. We can see such 2 balls, and we can exchange one position, and then jump up again. Know if you want to move, keep moving, and then come to the next ball. From this position, he starts to move to the right. At the same time, does the ball also start to go down? So we found such a key for almost 2 seconds. We really want to add a track for such a skill, so similarly, we add another track under this baseball track, and then punch a key pin for him in 2 seconds, and then punch the first changed key value for him in 2.5 seconds. What is the changed key value? Right? It's just moving here. So we all use 50 as a calculation, so this is at 230 phase, and then a y-axis here becomes a 350, and then go down to a position of 3 seconds. If it's at a position of 3 seconds, its y-axis becomes a 300 x-axis, and a 180c. We forget to set its track type, so change the track type to a straight line. Then keep looking, and when this side jumps over, what will happen next? When the ball starts rolling back, do the 2 balls also start rolling right? So we found the position where we want to start rolling back. Is it in the position of 4 seconds? Let's first make the position of such a ball, put a key needle in 4 seconds, and it will start rolling back. Rolling back is actually going back to where? Is it going back to its initial position? So we copy the initial needle, and then paste it in a position of 5 seconds, then it can roll back automatically. We can have a look at the effect. Roll, jump, get back here, right. So when we hit this side for 4 seconds, the ball will also roll, so we hit a key needle in 4 seconds, and then copy its initial position, and then paste it in 5 seconds. Is our effect good? We can have a look. It doesn't seem quite right. Why is there such a problem here? Because for our baseball, won't there be any change between this position and this position? So we should also set its x to an effect of 87, so we return it to 87. Look, the rotation degree here is 360 degrees, and 1 degree here should be 360 degrees. Okay, let's see if there are any problems. In this case, we will do a good job in such a slow effect. Then we add a little more details, such as let it loop and autoplay, we check it, and then we want it to play faster, such as a 5 times speed play, and then we can preview it to see an effect of the whole body. For 5 times speed, you can roll very fast. Of course, you can slow down a little bit. Let's have a 2 times speed play here. We can have a look at the effect of such a baseball bat. So what's the most important for us to do a case of this kind of timeline? That is, we must find the position of each key frame, because the animation between frames is calculated by our transform, that is, our transform. Therefore, we can only set it at a position of each key frame, and we don't need to calculate the rest by ourselves. The browser will help us make a calculation count. Then did you find a very beautiful thing, that is, this track just happens to be a love. It's really like loving you in baseball. Therefore, we don't think it's a very good skill to take out this track for a confession in any festival after learning it well. The above is all the content of this section. Thank you for watching.